Hi my scholars, this is my school channel and my name is Abiola. Right here in this video lesson we are going to walk through the subject chemistry for JAMB CBT past question the year 2010. Do not go anywhere, stay with us and we'll be right back. Welcome back to my school YouTube channel. Right there we are going to solve questions 26 to 49. So let's start with question 26. If a reaction is exothermic and there is a great disorder, it means that there will be a large decrease in the free energy. All right, so when you're talking about a reaction, a chemical reaction, you know, there's somehow that I can build on the concept of thermodynamics. You know, thermodynamics deals with the relationship between heat and other forms of energy. All right, so we have the first law of thermodynamics, we have the second law. So in the second law, we have factors that actually determine the spontaneity of a reaction, okay, of a process, of a chemical reaction. So we look at factors like the enthalpy, we look at the entropy, and the free energy. All right, so looking at this concept that I've just thrown out right now. So if a reaction is exothermic and there is a great disorder, entropy is about disorderliness, okay, of a particular process. So when there is a disorder and the reaction is exothermic, this tells you that there is a combined changes, okay, between enthalpy and entropy, okay, which means that the reaction will be spontaneous, making the free energy negative, so that we can have a large decrease in free energy. Typically, all these factors come together so that we can have a spontaneous process or a spontaneous reaction, okay, and this means that there will be a large decrease in free energy, because if free energy should be positive, okay, that reaction will not be spontaneous. All right, so if it is zero, that is another condition for equilibrium. So of course we are talking about the context of the question here. So if a reaction is exothermic and there is a great disorder, it means that there will be a large decrease in free energy so that the reaction can be spontaneous. So option D is the correct option. Question 27. In the preparation of oxygen by heating potassium triiosochlorate 5, okay, in the presence of manganese 4 oxide, okay, only moderate heat is needed because the catalyst acts by doing what? All right, first let's talk about oxygen. You know, that is the most abundant element on earth, and again in the lab preparation of oxygen, you know, you can use the decomposition of this potassium triiosochlorate 5, or you can use the decomposition of, or you can say the catalytic decomposition of hydrogen peroxide. As well, you can talk about the oxidation of hydrogen peroxide, okay? Or you can even use the thermal decomposition of mercury 2 oxide, lead 4 oxide, and some other processes like that. Okay, so now let's come back to this question. So we are told that in the preparation of oxygen by heating this, all right? So we know that anything around 400 degrees Celsius, that is when this will slowly release oxygen. Okay, that is in the absence of catalyst. So manganese 4 oxide we are seeing here is a black powder, all right, that is in combo with this, all right. This is 4:1. That is probably, if you are using 20 grams of this, you'll be talking about 5 grams of this. So this catalyst actually lowers the temperature and they release the effectiveness, or it makes the process faster. All right, so at a lower temperature. So you don't need to heat up to 400 degrees Celsius before you can get the release of oxygen. All right, so that is the work of the catalyst that we have here. So in the presence of this catalyst, how does the presence of this catalyst now actually get you the result that you need? So only moderate heat is needed because the catalyst acts by doing what? Now this is actually what the catalyst does. It increases the rate of the reaction. How exactly? By providing a new reaction path, okay, with a lower activation energy, or you can say with a lower energy barrier. Or you can also talk about the presence of this catalyst manganese 4 oxide, okay, in its presence, more particles will gain kinetic energy that is more than the activation energy or the barrier energy, which leads to effective collision between these particles. All right, and in turn that comes to the increase in the rate of reaction. So the major purpose of this catalyst is that only moderate heat is needed because the catalyst acts by increasing the rate of the reaction. So option C is the correct option. 28. So the graph above demonstrates the effect of what? So if you want to consider factors that can influence the rate of a chemical reaction, so you can talk about factors like the nature of the reactant, you can talk about the concentration or pressure if you are pointing to gases, okay, you can talk about the effect of catalysts, the effect of light. So as well, you can talk about surface area. So you can see that there's a comparison between powdered marble and marble chips. So when you're talking about surface area, okay, in a chemical reaction, you're talking about how much exposure, okay, you are giving to reactants that are actually solid. Let me just take solid in this instance. So, you know, once you increase the surface area, that means you have increased the area that is exposed for physical or chemical attacks, and that is what happens here. So there is going to be more reaction in with the powdered marble compared to the marble chips. Okay, because there's a larger area surface for contact. So the rate of reaction here will be faster, all right, in a given time. So the graph above demonstrates the effect of surface area on the rate of reaction. So option A is the correct option. 29. So we have what happens to the equilibrium constant of the reaction above if the temperature is increased. So at first you can see we have a negative value. So this tells you that this is an exothermic reaction. So for an exothermic reaction, if you increase the temperature, what is going to happen is that the equilibrium position will shift to the left, okay, and that will cause a decrease in K, your equilibrium constant, and that favors the reactant formation. All right, so what happens to the equilibrium constant of the reaction above if the temperature is increased because it's exothermic? What you will notice to the value of this, it will decrease. So option C is the correct option. Question 30. So to a solution of an unknown compound, so let's just clarify this, okay? The unknown compound here is aqueous triazonitrate 5. So just say to a solution of triazonitrate 5, a little dilute tetraisosulfate 6 acid was added with some freshly prepared iron 2 tetraisosulfate 6 solution. So the brown ring observed, all right, so this is a brown ring test, okay, for triazonitrate 5 ions. So the brown ring observed after the addition of a stream of conc H2SO4, this is H2SO4, confirmed the presence of this ion, triazonitrate 5 ion. So the brown ring test is for triazonitrate 5 ion, and this brown ring can actually disappear if you shake. Okay, so the correct option is option D for triazonitrate 5 ions. Number 31. So which of the following is used in rocket fuel? So when you talk about rocket fuels, we are looking at triazonitrate 5. Okay, so this can be used as rocket fuels when it comes to your TNTs and dyes. All right, this is ethanoic acid. So ethanoic acid, of course, is used when it comes to, you want to talk about solvents, dyes, you know, your vinegar and the like. So this is ethanoic acid, not ethanol. So if we had ethanol here, we would have compared or probably bring up ethanol against this, okay, as their usage for rocket fuels. All right, so H2SO4 and HCl, they are used when it comes to pickling metals amidst other usage. So the correct option is option A. So which of the following is used as a rocket fuel? So we are talking about option A, triazonitrate 5 acid. 32. So a constituent common to bronze and solder is what? All right, so at first this comparison is about alloys. So you know, an alloy is a homogeneous mixture, okay, of two or more metals. Sometimes we can involve non-metals like carbon. So when it comes to bronze, we are looking at a very high percentage of copper and a lower percentage of tin. Talk about solder, we are looking at almost the same percentage of lead and tin. So when it comes to bronze and solder, tin is the common constituent. All right, so a constituent common to bronze and solder is what? we are talking about tin found in option D. So option D is the accurate option. Question 33. When iron is exposed to moist air, it gradually rusts. This is due to the formation of what? Okay, so we talk about corrosion of metals. So when iron corrodes, that is referred to as rusting. So iron actually rusts when it is exposed to oxygen in the presence of water. So just like burning, rusting of iron and burning, they are both oxidation processes. Okay, even though rusting is slow or slower to put. So what we see as rust, okay, it is due to the formation of hydrated iron 3 oxide. So the correct option here is option A. 34. A compound gives an orange-red color to non-luminous flame. This compound is likely to contain what? Alright, so when you talk about a non-luminous flame, we are talking about a region where there is complete combustion. Alright, so the compound that gives this particular coloration, okay, this whole setup is flame test. Alright, so this color is actually, you can attribute it to calcium ions. Okay, some presentation will tell you, oh, this flame test result for calcium ion is brick red. All right, some will say red orange. Here we have orange red. So this is the answer. When it comes to sodium ion, you are looking at yellow. Okay, some will tell you persistent golden yellow, brilliant yellow, and the like. So ion 3 ion, you talk about brown. Okay, so some can tell you yellow, but let's just stick with brown. Ion 2 is now the green. Some will tell you pale green and the like. So let's just take it again. This is green, this is brown, this is red, okay, this is yellow. So the correct option here is option B for calcium ion. Number 35. So stainless steel is used for making what? Alright, so stainless steel, actually its constituents are iron, chromium, and nickel. Okay, so we are talking about transition elements, and these elements, they belong to the first transition series. You know, if you stop at calcium, which is your 20th element on the periodic table, then we are moving to the next one, 21, 22. So you can count scandium, titanium, vanadium. Okay, then you have your chromium, right? Chromium, your manganese, your iron, your cobalt, your nickel, and your copper, then zinc. Okay, so you can see the chromium is 24, iron is 26, then your nickel is 28. So we are talking about the transition elements right here. So they come together and we have the stainless steel. So the stainless steel is very hard, it is resistant to corrosion, and as well it has attractive appearance. So you can use it for these tools, you know, your cutlery, and even for surgical instruments. So this steel is used for making, stainless steel now is used for making tools. Okay, so when it comes to your magnets, I can talk about alnico. Or when it comes to coins and medals, I can give it to bronze, okay, or your bronze. Then when you come to moving parts of clocks, we are looking at brass. So this is brass, bronze, this is stainless steel, and this is alnico. So the correct option here is option B for tools. Of course, you can have a JAMB CBT simulated experience. How do you do this? Just click on the link in the description below. It's going to get you to the Myschool website. Right there, you can download the Myschool mobile app for your Android devices, or you can get the Myschool software for your laptops and your computers. So join me as we solve question 36. So the residual solids from the fractional distillation of petroleum, or I can say crude oil, are used as what? Okay, so they are used as coating of pipes. You know, we are talking about residues like bitumen and others. All right, so you can use this for coating of pipes, or you can say pipe coating, you know, as protective paint and the likes. So when it comes to the other options, you know, raw materials for the cracking process, the fractions that are responsible for this, they are the diesel oil or the gas oil. Okay, when it comes to fuel for driving tractors or for giant engines, you can use your kerosene. So the correct option here is option A for coating of pipes. Please do not forget that you just have to hit the like button. Also click on the subscribe button and always tap on bell notification so you can get alert immediately we upload the next video content just for you. Number 37. So we have this. Okay, so the IUPAC nomenclature of the compound above is what? So at first you have to name according to the longest unbranched carbon chain. Okay, so even though it may not be horizontal, so let's just do this together. Let's count the carbons that we have available. All right, just take note of this properly. And this is a substituent. Okay, so just look at this. We have 3 carbons here. So we have 3, we have 1 here, making 4. We have how many carbons here? That is 3, right? So we have 4 plus 1, that is 3 plus 1, rather that is 4 plus 3. Okay, that is 7 plus the last one, that is 8. So, and you can see there are no double bonds or triple bonds here. So you are talking about the alkanes family. So number 8, carbon number 8, that is, we are talking about octane. All right, so this is definitely going to be octane. So let's now look at this substituent. So you can see it is actually resting here. All right, so what carbon chain is this? So this is what we are going to do. We are going to make sure that we assign the proper name to this compound. All right, so that we can have the lowest number possible in respect to this substituent. Okay, so the lowest number possible will be this. Okay, so now let's try it out. We have 3 here, this is 4. You can see that. So that's going to be ethyl. This is the alkyl group, of course. So you can see ethyl. Remember your, let me just take it this way, your mets. Okay, or let me just say your methyl, your ethyl, your propyl, your butyl. Do you see that? Your pentyl. And the likes like that. So this is definitely ethyl. So we can see, you can see it's on number 4. It's resting on the 4th carbon chain. So you can say 3, 4. So the IUPAC nomenclature of the compound above is what? 4-ethyl, right? Octane. Remember the carbon chain. So 4-ethyl octane. So the correct option here is option A for 4-ethyl octane. 38. Which of the following is used as fuel in miner's lamp? Okay, so we are talking about the ethane. All right, so this is ethanol. You know, when you're talking about ethanol, you can point to perfumes, flavors, and the likes. Okay, so when it comes to ethane, okay, ethane here is very useful when it comes to fruits ripening. All right, then we have ethane. Generally, when you talk about gaseous or liquid alkanes, you know, your methane, your ethane, your propane, they are very good sources of it. So the correct option here is option B for ethane. Question 39. So which of the following organic compounds is very soluble in water? Very soluble in water. So let's identify these compounds. Ethanoic acid, ethane, this is ethene, right, and this is ethyl ethanoate. All right, so that is very settled. So we have ethanoic acid is very soluble in water, though we know it's a weak acid, but it's very soluble in water. This and this, they are spirally soluble in water, and this is slightly soluble in water. So the correct option is for ethanoic acid. So we have option A as the accurate option. 40. So benzene reacts with hydrogen in the presence of nickel catalyst at 180 degrees Celsius to give what? All right, so we know that benzene is an aromatic compound. Of course, it's gotten from, you can get this from destructive distillation of coal, right? So, and again, we know that benzene has a very nice smell, sweet smell. Okay, so the chemical properties of benzene, you know, it can undergo substitution reaction, then addition reaction. So what we are saying here is actually addition reaction, okay, which involve benzene and hydrogen, benzene vapor and hydrogen, the presence of nickel catalyst to actually give you cyclohexane. So the correct option here is option D for cyclohexane. Question 41. So which of the following is used to hasten the ripening of fruit? So this is for ethane, or you can refer to it as ethylene. All right, so we know ethanol can be used for fuel when it comes to your racing cars or your rockets. All right, then we have ethane. Of course, this is for miner's lamp. You can use that as well. Then ethane, you know, ethane, methane, like I mentioned earlier, you can use them as source of heat. Okay, so the correct option here is option A for ethane. Question number 42. So the final product of the reaction between methane and chlorine in the presence of ultraviolet light are hydrogen chloride and tetrachloromethane. or tetrachloride. All right, so we are talking about alkanes here. You know, alkanes, they are saturated compounds. So we are picking methane as case study. So we can see for chemical properties, okay, regarding methane, we can talk about combustion. You know, this burns with a pale blue color, flame specifically in excess air to give you carbon dioxide, and we'll talk about water. All right, so for methane, that is combustion reaction. Another reaction it can undergo is substitution reaction with this chlorine. Of course, it happens with a bromine as well. So this acts as the catalyst in this substitution reaction. So this is how it happens. You know, chlorine is CH4. So an atom from chlorine will go ahead to meet methane, right, and replace hydrogen there, a single atom of hydrogen there. So you can see the reduction goes on, the exchange goes on like that till you now have your final product of this giving off as gas, hydrochloric acid, and tetrachloromethane. So this is how it begins. Okay, so the first product you are going to get is chloromethane. All right, so right there you have 3 hydrogen atoms present in methane, okay, in this particular setup. So it's not going to be CH4 here, it's going to be CH3 right here. Then from there we move to dichloromethane. So that means in this place we have 2 chlorine atoms, 2 hydrogen atoms. You get that now? Then we have the trichloromethane. So we have 3 chlorine atoms, 1 hydrogen atom. So right there you can see we have the tetrachloromethane. So right here we have 4 chlorine atoms and no hydrogen atoms. So that is CCl4. Okay, do you see that now? So it's just a substitution reaction whereby a chlorine atom comes here to replace hydrogen atom. So the correct option is option C for tetrachloromethane, and this is very useful, of course, when it comes to anesthetic in surgical operation. That's trichloromethane. So we have option C as the correct option. 43. The correct order of increasing boiling point of the following compounds is what? So when you look at increasing boiling point, so in the order of increase, right? So we are talking about from the lowest to the highest. So first, let's identify this compound. This is propanol, right? This is heptane, and this is butane. So this is gas, liquid, liquid. All right, so this has boiling point. At least I can put it around -1 degrees. Okay, this is 98 point some figures. Okay, so let's just say 98 basically. Then this is 97. All right, so let's arrange this from the lowest to the highest. So this is the lowest. So it's going to be butane, right, to propanol, then to heptane. So now let's see, where do we have that? I think we can find that in option D. So option D now has the correct option. So arranging the boiling point, okay, in the order of increasing value from the lowest to the highest, then I have this. So option D is the correct option. Question number 44. So one of the major uses of alkane is as domestic and industrial fuel. All right, so option A is correct. Now, in the hydrogenation of oils, we are talking about margarine. Okay, that is where you use hydrogen alongside oil, maybe from your oil palm. Okay, so in the presence of nickel catalyst. So now for the textile industries and in the production of plastics, we can talk about ethane right here, specifically polyethylene. Okay, so of course ethane is as well involved in this process. So I can give it to ethane. This is hydrogen, okay, alongside oils, presence of nickel catalyst, and this is for alkanes. Just like you recall that methane burns with a pale blue flame, okay, in excess air to give out carbon dioxide and water. So you can see they are very good source of domestic or industrial fuel and industrial fuel. So option A is very viable. 45. So the haloalkanes used in dry cleaning industries are what? Okay, so just take note of this. They are trichloromethane and tetrachloromethane, as well trichloroethane. All right, but if you look at the combination where we find trichloroethane, okay, so the other part makes the option invalid. So the correct option here, that's what we have, option A. So trichloromethane and tetrachloromethane. So the correct option is option A because these are important organic solvents. We are very eager to entertain questions from you. So how do you ask your question? It's very simple. All you just need to do is to click on the link in the description below. It's going to get you to my school website. Right there, you get to meet with our solution providers. So join me as we solve the next question that we have right there. So we have two hydrocarbons, X and Y, were treated with water, with bromine water. All right. So X decolorized the solution and Y did not. Okay, so which class of compound does Y belong to? So at first, I want to establish that these letters X and Y represent hydrocarbons. So that should be between paraffins and olefins. Paraffins, I'm talking about alkanes. Olefins, I'm talking about alkanes. All right, so X is definitely an alkene. All right, because with them, where they decolorize bromine water. Even when you try to brominate ethane, right, using bromine, of course, you still get a decolorization. So even when you are using bromine water, you are still going to get a decolorization. So at first, let's establish that X is an alkene, but we are asked to identify Y. So I can see this test as a setup to distinguish between the paraffins, that is the alkanes, and the alkenes. So definitely Y should belong to the class of option D, alkanes. We believe that you may have better steps or perspectives regarding any of the questions we have solved so far. Please, we are so much interested. All you just need to do is to use that comment section below. Kindly indicate the question number and the explanations or suggestions you'd like to share. Question 47. So the compound that is used as an anesthetic is what? That is chloroform or trichloromethane. All right, so as well you can use it to preserve biological specimen. Okay, so this is tetrachloromethane. Okay, so we use this as an important organic solvent as well. Probably you want to remove stains. It's also useful when it comes to fire extinguisher. So we have option C and option D. This is dichloromethane and this is chloromethane. So the correct option is option B. Question 48. In the diagram above, the purpose of the asbestos is to do what? Okay, so this process you are seeing above is also what you see when it comes to contact process, okay, for the industrial manufacture of tetra or sulfate 6. So basically this experiment is set up, okay, to yield or to prepare sulfur 6 oxide. So ordinarily we know that sulfur 4 oxide will not combine with oxygen to give you sulfur 6 oxide. So you just have to influence the process. All right, so how do you do that? You use this platinized asbestos, or you can use vanadium 5 oxide as your catalyst. All right, then as well, you can work around the pressure, maybe a slight pressure, then temperature around 400 degrees Celsius or the like. So in the diagram above, the purpose of the asbestos is to do what? Okay, it is to catalyze the reaction so that it can occur. All right, so the correct option here is option B. 49. So in the diagram above, the gas produced is what? Okay, so this is a setup for nitrogen 2 oxide. Option A, okay, this is nitrogen 4 oxide. This is where you have the use of U2. Okay, then here we have nitrogen 1 oxide from the thermal decomposition of ammonium triazonitrate 5, and this is dinitrogen tetraoxide. So the correct option here is option A for nitrogen 2 oxide. We've come to the end of this great video lesson. I believe you've enjoyed it. So all you just need to do is to remember that there are much more content to come, and you just have to hit the like button. Also click on the subscribe button and always tap on that bell notification so you can get informed immediately we upload the next video content just for you.